Thanks for joining us for our webinar on boosting manufacturing operations with 3D printing. So joining me on the call, I have some esteemed colleagues from Markforged, Richard Alving, who's the Director of Sales for the APAC region, and one of his colleagues, Anthony Rosengren. I'll be handing over to them a little later in the presentation. So without further ado, I will get started, and we can rip into this. Please, if there are any questions, feel free to type them in the chat window. We'll try and get to them during the course of the presentation, or we'll cover them off at the very end. So what is this all about? Boosting manufacturing with 3D printing. I think to really understand that, we've got to go back a little bit. And as much as people don't really want to talk about COVID, COVID has accelerated a number of issues that manufacturers are facing here in Australia. Very few of us have a natural immunity to COVID, neither do our businesses. It can make and break us, and part of what's happened is issues with supply chain, and that has generated an upsurge in demand for Australian-made products. That's great news for us all here, but there are a couple of headwinds that sit in front of that, and part of it is about discussing that supply chain and how that impacts manufacturing here in Australia. To do that, just a really brief overview of, I guess, 100 years of centralized manufacturing. These processes have been honed over hundreds and hundreds of years to become efficient and cost effective. But along with that efficiency and cost effectiveness, it creates issues when you come across supply chain issues, or we see what's happened recently with the impact from COVID. We're separated from our supply chains from by a vast ocean, and that creates many issues for businesses when an issue like COVID hits, and it can take various forms, but in essence, being separated from parts or product that you need to help you manufacture product here in Australia. And it can be not just that. There are other issues at stake here, and I'll discuss a few of those concepts during the course of the presentation. It could be that it's not just supply chain, there's obsolescence issues. It could be that the cost of the parts and the products that you're ordering from overseas have increased tenfold, and you need to gain efficiency here in Australia by figuring out another way of manufacturing. There's a number of different impacts, and they all have an impact on the way we traditionally manufacture as the global conditions work against us. So where does this take us? I guess what we're kind of saying is the way things are being made is changing, and if you have a look at the left-hand side of that slide, raw material, manufacture, ship, and then that goes into your inventory. Really, what organisations in Australia are now looking towards is a digital on-demand inventory. That is, it's a part that exists on a computer or in the cloud somewhere that you've designed. You print that, it becomes a prototype, or you print that, it becomes a product, or you print that and it becomes a tool that's going to help you make your end product in a fast, efficient, and cost-effective way. And so this is becoming more and more prevalent in Australia and across the world. Obviously, lots of manufacturers have gone this way. Many in Australia, many large names in Australia are doing this. But really, what I think is driving the change, and I would like to step back and just point to the whole prototype versus product, and what that to me means: prototype versus an end-use part. And I think people have this opinion that 3D printing is about prototyping. Prototyping is still a valid use for 3D printing, don't get me wrong, and people use it all the time for that type of work. But what is happening more and more often, in the fastest growing part of 3D printing, is using those parts in an end-use application, and that is the job that the part is designed to do. And what's changing, and what's making that or changing that growth and speeding that growth up in 3D printing really is the materials that are driving the change. If you have a kind of think about it, there's probably a dozen, maybe more, methods of 3D printing that have been in the market for some time, are quite refined processes, um, but they change that does, so that changes a little bit, but not really that fast. What changes exceptionally fast is the research and development that goes into the actual materials that you can print in these printers and in these products. Um, quite often we see a product launch of a piece of hardware, a printer, and then very quickly thereafter, lots of research and development going into that product and new materials launching for that product on a monthly basis. We're talking about metals. We're talking about composite materials like carbon fibers, soft rubbers. If you can think of a material, there's a high likelihood that there's a capability to 3D print it or layer it or use additive manufacturing to print it. So um, that's a massive step change. And going back to, I guess, the conversation around that step change from really just seeing it as a method of prototyping and then going to a mass manufacturing process. What we're seeing is people seeing this as a legitimate way of actually manufacturing an end-use part because the materials are stronger or they perform like a material that they need, or that material potentially performs even better than an existing material that they're using, and they get a benefit out of switching to a different material or 3D printed material. So that's a really important factor. That it really is, in my mind, the number of materials and the types of materials you can print that have changed it. And just to kind of give you an idea, um, about 3 to 4 years ago, I think, end-use parts coming off of 3D printers. Now, if you think of 3D printers globally, there's a number of them out there that all the parts coming off them, it was something like only 10% of those parts were used in end-use application. That's grown to over 30% now. In a really, really short period of time, and that's due to the types of materials that you can print in. Um, so what else is creating this change? And I think the other aspect to this, and how people are applying this technology in manufacturing, is really to sit back and actually think about the parts that they're designing or using, and that's applying design thinking principles. It's no longer about, I guess, being constrained by the manufacturing process. What you can really step back and do is try and design the perfect part, and not be constrained by the angle that a tool can mill at, or um, these other constraints that mean really what in the past you would have been doing would have been designing for the manufacturing process. You can actually kind of almost flip that on its head and go, I can design any geometry in any manner that I like. What I want to do is design the perfect part. And there's a couple of different concepts that people are using, and I'll show a couple of them on the slide there, and I'll talk about another kind of example of that in the next slide. But really, a simple one is, if you have a look at the bottom right, bottom left picture, sorry, is part consolidation. So that's thinking about the part and what it does in context of what else it fits in with, and going, can I design that as one piece? Now, probably it speaks for itself that there's advantages in that being one part rather than having to carry multiple parts and then put that together. And those would be just purely carrying less inventory and less stock. It might be less quality control. You don't have to check all those parts have been fitted together properly before they go into something. Consolidating it could make it lighter. There's a bunch of benefits and reasons why part consolidation is a big driving factor. And the other is things like lightweighting. So I guess the image on the right, performs like a solid part, but is a third of the weight. Now, when you're talking certainly aerospace, you're talking transport and logistics. Even something simple that, maybe that's an actuator arm that's spinning around at, hundreds and hundreds of revolutions a minute, and that puts a lot of load on the machinery. Lightweighting that part can have a massive impact. And so that's what I kind of mean when I'm talking about designing the perfect part. It's really thinking about what your problem is, and designing a smart part that overcomes that. And I really wanted to give you a really short snapshot of a concept that I came across that I think kind of resonates to this, and this is kind of sort of stuff that people are doing already here in Australia. Very simple slide. Um, the concept is that they're an organization. They have that motor fitted into a piece of, maybe not that particular motor, I've just pulled an example offline, but they have that motor fitted into a processing plant. Um, when they have an issue with that spur gear in the middle, um, they actually have to get an electrician to come and remove the motor, and then their maintenance engineer removes the spur gear from the shaft. They replace that. That all goes back together. The idea is then that you redesign the spur gear into two halves, so you no longer need the actual electrician to come disconnect the motor, remove it before you can replace the spur gear. So in some instances, it could be actually that the 3D printed part is more expensive than the original part. But when you look at the whole process behind replacing that, well, that's a machinery that's in situ, that it takes a lot of cost out of that whole process, and actually makes that more efficient. So, what does that mean? It means if you get a breakage of that spur gear, you can replace it faster, you're back into production faster, you're making money faster, and you're doing it cheaper. All right, so people are taking advantage of these concepts to keep themselves operational in a really smart and cost-effective way. And typically, what we find happens is people get this type of equipment. All of us, and most of the people on this call, will have a bunch of really, really smart people working in their organizations that have ideas on how they can overcome these types of issues if you put the right tools in their hands, right? and and so um, that's the interesting part of that is what we typically see when people adopt this technology is that the use of it explodes really quickly as people start to understand this lateral thinking around overcoming issues. And you'll find, right, that your maintenance engineers, the guys that are on the ground doing the job, they'll know the common failure points, and they'll be putting that same part in, and they'll go, gee, if only they redesigned that like this, or added a feature to it, it would last 10 times longer. um, and so you can actually take that and then apply that to a part, put that back in situ, and actually not only gain the advantage of maybe making it easy to fit, but getting longer use cycle out of the part, so remaining productive for longer as well. So there's really this double kind of payoff, or triple payoff potentially, around using 3D printing in those types of settings. Um, Last slide for me. I really wanted to kind of just recap before I hand over to Richard and Mark Forged. How does digital manufacturing add value? Well, just basically, cost of a part. It may well be that at the moment manufacturing that part here in Australia with a 3D printer is cheaper. As I said, you can redesign that part to get better part performance. It might be a physical redesign of the part. It might be printing that in a material that you haven't had access to before to get more longevity out of the part. I spoke a little bit about reducing downtime and how people are using, I guess, smart design to reduce downtime. Overcoming obsolescence is a bit of a no-brainer. We're all trying to sweat assets longer. And you think about that, the company that used to manufacture it's no longer in existence. You have to reverse engineer that part and make it from scratch. 3D printing is a great way of doing that. Um, Printing on demand, inventory optimization. So imagine not being a slave to minimum order quantities, right? You know, you know, it's one cog, but to be cost effective, I have to order 40 of them and put them into stock. Just print one and carry one in stock, right? And that reduces inventory cost. Potentially reduces import taxes, improves logistics, right? And then local production, last mile logistics. And what I kind of mean there is um, manufacture what you need, where you need it. And that's putting the tool in a location where you're going to need the part, and printing, click file, print. It's ready in a few hours or ready the next morning. And so, those concepts are, pretty heavily explored here in Australia, and there are organisations that have been taking advantage of this for a number of years already. And, really with, the change in materials and I guess the cost effectiveness now of adopting the technology, organisations are really going down this path. That's probably everything that I wanted to cover. I'm going to hand over to Richard in a second here. But I guess as part of that, what we wanted to talk to you about was a recently launched product from Markforged that we think has, a really strong application in manufacturing here in Australia. The Markforged products are very well thought of. They've been in the market out here for some time, and we've got a number of manufacturing customers that are taking advantage of that product. But really, this is the next evolution. And I think, as Richard goes through his presentation, you'll probably see some themes come out that I've kind of really broadly touched on in my part of the presentation. One of those will be materials, which I think is quite exciting. But I guess without further ado, I will hand over to Richard Alving from Markforged, who is going to talk to us a little bit about their new FX20 product. Thanks, Richard. Thanks for joining us.
Hey, Matt, thank you so much. Pleasure to be here with you guys, and really appreciate the opportunity. Thank you, Konica Minolta, for organizing this. So I really first wanted to kind of introduce myself for you guys that's on the call that I haven't met. As Matt said, my name is Richard Alving. I'm the director for Markforged in Asia Pacific. I'm based in Australia. I've spent the last 15 years in the manufacturing industry. I've visited over 3,000 factories to help manufacturers with a lot of common challenges. And what I've seen in the last 15 years is that, hey, we want to reduce costs. We want to get to market faster. We want to innovate faster than the competition. That has not changed 15 years later. However, in the last 18 months or so, a fourth major challenge has appeared, as Matt already touched on. Think about all the ways that your organization has been impacted by supply chain disruptions. I know certainly that we've been affected at Markforged, and a lot of our customers have said, hey, products have, that they're purchasing has gone end of life. Vendor pricing has gone through the roof. People have lost, manufacturing staff, and has gone through a lot of challenges. So this is really what we are looking at, helping manufacturers with these four major challenges to overcome. So what we do at Markforged, we make a platform called the Digital Forge. So this platform consists of hardware, consists of software and materials, and we've designed these to work seamlessly together so that you as an engineer or a product designer can go directly from your design to a functional part with a click of a button. Doesn't get much easier than that. So the platform is also smart and connected. So this enables organizations to scale and distribute manufacturing at the point of need, and helps you overcome some supply chain challenges, right? The thing with replacing conventional manufacturing parts, you do need strong, good materials, and Matt touched on this also in his presentation. So I think with Markforged innovation is that you have this potential using the Digital Forge, and we've taken this traditional FFF, which is fused filament fabrication technology, which uses a nozzle to build up plastic parts layer by layer. And we've augmented that by reinforcing parts with continuous fiber, including carbon fiber. And these fibers, they act like a rebar, just like that a rebar does for concrete. It adds this incredible amount of strength and stiffness to your composite parts. So the parts that are printed on Markforged printers can't really be compared with other printers. They are much, much stronger, and they are, aerospace grade, quality in terms of aluminium with a lot less weight. So if you look at some of these stress strain curves that you can see here on the right, you can see how the continuous fiber parts perform compared to typical engineering grade thermoplastics at the bottom, right? And even compared to 6061 aluminium, with these carbon fiber parts, they can really handle the most demanding applications. The other key here is to have the right infrastructure to scale operations. So we use this cloud-first architecture. This brings a lot of benefits to users, whether you have one printer or whether you have hundreds or even thousands of printers at the point of need. So to scale from one printer to go to dozen sites across Australia or across the world is very, very easy by just putting the box where you need it and using our Eiger Fleet software. And using this type of enterprise software, you can be rest assured that our products are ISO 27001 security approved, which means that your entire enterprise organization can use Markforged digital infrastructure wherever you need it. So FX20, right? The reason why we're here, we've really extended the possibility of what the Digital Forge can do. And you might ask yourself, like, why did you guys build the FX20? Well, at Markforged, we're fortunate enough to have customers around the world that are providing us a lot of good feedback. And through a lot of customer surveys and lots of customer conversations, we've had a lot of feedback that, hey, we love your product. We love the strength. We love the accuracy. We love the surface finish. We love the reliability. But we just wish we had ... So let me tell you what the wishes from our customers that are using Markforged Digital Forge are. Hey, you asked for bigger. This is where FX20 really delivers. So the build volume of the FX20 is 5 times larger than our current largest X7 printer, right? So you can print dramatically larger parts or larger amounts of parts unattended in a single build, right? So that's kind of like the number one request. So the great thing here is that we're able to do these large parts with continuous carbon fiber, and you'll be able to do multi-part assemblies into a single part, which will save you a lot of time having to break up CAD files if you're printing with traditional printers or other Markforged printers. So this naturally will open up a lot of new applications, and of course, which customer doesn't want bigger, accurate parts, right, in a single build? Next point of feedback is faster, right? We've gone as big as we have, which is as big as we can do with using the technology. But the other thing is that we can't just print at the same print speed, right? Because then it will take a lot longer. Using new technology, we've been able to increase the speed with 8 times faster than the default settings if you're a user of a Mark II or X7, which is our smaller composite printers. And we do this, remember, printing 8 times faster, it's kind of like saying, hey, can you release a car that goes 8 times faster? And at the same time, we need you to maintain and even improve the part quality and improve the accuracy of that. So that's what we've done with the FX20. So here you can kind of just see how that compares to our other printers. So imagine something that takes 8 hours to print using our desktop printer. Now you can print those parts in an hour, essentially. Okay, what other feedback did you give us? Hey, we want hot. Okay, you want hotter. So for the first time at Markforged, we are printing these high temperature thermoplastics. And not only that, we're also the first company to really reinforce these with continuous carbon fiber. So introducing Ultem 1985 filament, which has high heat resistance, it's got chemical resistance, and flame, smoke, and toxicity compliance. So these properties will enable end-use applications in industries like aerospace, defense, transportation, automotive, oil and gas. So it's an amazing material, which is really going to unlock a lot more applications. And being able to do this for the first time with this Ultem material plus continuous fiber is a game changer. So the other thing here is smarter. Okay, no one really asked for things to be smarter, but there's a lot of things that a smarter platform enables. So if you think about it, the Digital Forge is able to collect data from our over 10,000 customers that all have connected printers and that are frequently adding more. So right now, every 10 seconds, a new part is being printed on the Markforged printer. And this every single print generates a metadata, which is then used to drive further insights, which will make the platform better, which will bring further improvements. And in return, customers like yourself are going to produce even better parts and products, using Markforged technology. So the FX20 was purposefully built to embrace this smart architecture, right? So where does that leave us? Hey, it leaves us here where, we have the factory of the future, which is around automation, and we have the requirements in the field from demanding end-use part applications, right? So this is really why we have brought out the FX20. So for you guys that are interested in some more technical highlights, I'm going to go into some of the technical details of the FX20. So, of course, this is a high-level overview. We talked about the Ultem. We're now just going to talk about our build chamber, the 3-nozzle print head. Of course, we have a large touch screen, and we have an advanced material cabinet. So touching on the build chamber, right? In addition to being big, it's not an exaggeration to say that FX20 was really like designing and engineering and manufacturing a printer plus an oven, right? The FX20's build chamber is capable of reaching over 200 degrees Celsius using this build chamber. It's got a multi-zone heating plus carefully tuned airflow patterns, which is helping us to produce these high temperature thermal uniformity of the parts, right? It's one thing to say, hey, we can print Ultem, but it's really the parts that the printer produced that matters in the end of the day, like we always say. This, of course, will have automated bed leveling, automated nozzle offset calibration as well, right? And of course, part removal is going to be very, very easy using removable print sheets. Then the other technical highlight is the print head. So how many print heads does the FX20 have? Does it have one? No. Does it have two? No. It actually has 3 nozzles. And each of these are associated with standalone print modules. So 2 of these nozzles are for plastics. In Markforged case, we use Onyx and we use Ultem. And of course, the third one is for the continuous fiber reinforcements, which could be carbon fiber, or could be Kevlar, or could be fiberglass, depending on what the application is. So this is something that's, again, we've never done before. Now, moving into the motion system. So this is an all-new design, which was precision engineered for performance. We're talking about the structure, the motors, the sensors, even to the file format to control the entire motion system. So the result is that we have a blend of high speed with accuracy, which is going to produce these incredible parts. So speaking of which, what type of applications or what type of parts are we going to be able to do with this technology? Well, without knowing everyone that's joining us for this call what your applications are, here are just some suggestions what you can do with the FX20. So for instance, if you're in the automation industry, it could be things like end of arm tooling and sensor brackets. It could be various covers and ergonomic trays, tools, fixtures, hand tools, covers, plugs, bumpers, you name it, right? It's all about printing components to keep your factory running so that you don't get bogged down with producing parts for your factory. Another example is aerospace. So we can look at things like wall panels, cabinet doors, latches, spare parts, ducting, housing, enclosures, you name it, right? So these are just some examples. In the end of the day, what really helps justify the FX20 investment is the ability to print these large functional parts, right? In the end of the day, it's one thing just to print a large part, but it's one thing to print a large part that you can go straight from the build plate into the application of your choice, right? And when you think about it, what long continuous fiber parts or parts can do, it's really whatever that you can imagine. So what I will leave you with is like example, hey, big functional parts. Do you have any large parts that you're looking at printing that needs to be strong? Are you currently using a printer where you need to split components up into multiple parts and then you join them in whatever process? Now you can obviously print these in one go, right? There's no assembly or joining of parts that is needed anymore. And of course, if you need applications that need high chemical resistivity, Ultem 9085 is excellent for this. And as we mentioned before, there could be some high temperature applications that you might need. So if we look into aerospace specifically, this is really where Markforged FX20 hits the sweet spot. And I will take a moment just to mention that these sweet spots are not just true for aerospace, but if you think about it, for Australian manufacturing as well. So what we mean with that low to medium volume, that's where both aerospace and Australian manufacturing is today. Gone are the days where we're mass producing components like cars in this country. Complexity is increasing, so we're not producing components in Australia that are very simple. It's all about solving some type of problem for customers, where we combine the best type of engineering and produce these complex parts. And then the other thing that we can offer down under is engineering components so that they perform better rather than using these mass-produced components. So that one of those examples could be weight reduction. So let's look at a customer example. We've been working with a company called SRC. They're an early adopter. What they produce is, they develop technology for radars and electronic warfare. They're, a company that's innovating. They have lots of customers within the defense force. And they came to us and said, hey, there are three things that we need. And also when we are looking at producing components for the Department of Defense, we need to reduce time to market. We need to optimize the parts for the application, and they need to be cost effective. And these are challenges that I'm sure can resonate with the customers that are on the line with us today. And we're looking at reducing, if we can, the space, weight, and the power, right? So using the Ultem 9085 filament to extreme, that can withstand these extreme environments, SRC was able to get a competitive advantage using the FX20 to produce these end-use parts for the Department of Defense. So they went from months to produce these components to days using the FX20. They were able to achieve 15% weight reduction, and they did not sacrifice any strength. They were also able to reduce 25% on their costs by eliminating tooling and outsourcing. Because if you think about it, like Matt said before, with 3D printers, you go straight from that CAD design into printing into a finished component. So there's no more going overseas or creating tooling or machining if we have the right application. So at a high level, why the FX20? Hey, you want to go big, you want to go fast, you want to go hot, you want to, the latest and greatest smart technology. This is really where the FX20 does not have any direct competition. So if you're looking for the best of the best, this is really where the FX20 would fit into your organization. So today I've given you a high level overview of why we developed the FX20, what customers were saying in terms of their feedback that were using our desktop and industrial machines, why we developed it, how we developed it, the challenges, and some early adopters feedback, how they've been using the technology. As a next step, we're going to be able to share the data sheet with you guys and the product brochure, I believe, here in this webinar with you. So you're able to use the links here on the side to download all of this information. You can see the exact technical details of the FX20. You can also see that, hey, we love everything about it, but maybe we're not ready for that. The good thing with Markforged is that we have now, a small offering, which is the desktop printer that can print these continuous carbon fiber components. We have mid-range, which is our industrial series, and then we have the production series. So in 3 completely different price categories. So whatever your budget might be, or whatever your application might be, there's now a printer that would suit those requirements. What I will also say that both Markforged and Konica Minolta, we are all about building this long-term relationship with you as a customer. In Australia, we already have hundreds of customers that are using the technology. We love to hear how they're reinventing manufacturing and reshoring back to Australia. And as a part of that is not just providing the latest technology and helping you with the installation and the support, but it's also really about enabling you. We have a program that is called the Markforged University. It's essentially a 3-day composite or a 2-day metal 3D design for additive manufacturing training that you can take online. So I highly recommend you to either as a customer or as a prospective customer to get access to this university training, which is really about optimizing your parts for 3D. And then in terms of evaluating printers, and then once you've made a purchasing decision supporting that, I'd like to just invite Matt back as well, because this is really where Markforged, as a Boston-based company, partners with Konica Minolta, which has great coverage across Australia and New Zealand, to really offer the support evaluation of parts that also post purchase help you with that. So Matt, do you want to just share a little bit about how you can help prospective buyers and customers as an organization?
Yeah, absolutely. Thanks, Richard. Quite often, we go through quite a rigorous process with customers, prior to them, making a decision to purchase a printer, a Markforged printer, and more often than not, that involves, working with one of our solutions experts and one of our pre-sales technical experts on an application. So that's really about dialing in with the customer on what their problem is. Have we got materials that can resolve that, and is it possible to print in a cost-effective way, and maybe even in the volumes that they require to overcome their problem, and really dial in on an ROI, on what the ROI is around overcoming that particular application. Typically, that all happens in a kind of a soft manner, right? So it's part assessment, maybe a physical part assessment, or a soft part assessment. Maybe that's a file you supply us from CAD, or and we put them in the hands of our technical people. They go away, they do their assessment, they come back, they go, this is how much we think the part's going to cost to execute on. These are the volumes that the machine can produce. These are the specifications around the part and the strength that we think we're going to be able to achieve. And once we dial in on that and everybody's kind of on the same page, it would be on to executing on a physical part for them. Maybe they go away, take that and assess that part, make sure it's going to do exactly what they wanted it to do, and then moves on to them adopting the technology. From there, it moves on to the post-sale side of it, right, which is what you were talking about, and that is really the support that wraps around the printer. So that is maybe you need additional support on part design, or maybe your part's really large and you're thinking about ways that you might be able to chop that up in a certain way that's going to make it work really nicely with the printer, we can dial those expertise in post-sale as well. And then along with that, obviously, these become a critical piece of your infrastructure, right? If they're not operational, you're down. So, and we want you to adopt this as a critical piece of infrastructure. We think it's important. It's no different to having a milling machine on the floor or a welder or whatever that is. Once you're reliant on it, it needs to be operational. And so we have physical resources in every state and every location that are trained to come on site and fix if you are experiencing issues. And we're scaled across the whole of Australia and New Zealand. So that's the kind of support aspect that we wrap around it. Obviously, we've got technical trainers in the country that train our engineers. So as we get more and more of this equipment into the field, we're scaling our engineering force to accommodate that. So that's kind of where Konica Minolta fit in and wrap around the product offering.
Fantastic. Yeah, I love that. So what I like to do is I like to open it up for Q&A. Just before you would do that, I just like to offer everyone that has joined the call today to reach out to Matt or myself, and we essentially, if you share the files with us or you share potential applications, we'll offer you a free consultative session to go through your applications and put together a proposal of how Markforged and Konica Minolta potentially can help your organization.
Absolutely. So I don't know, were we going to bring Anthony on or as well?
Sure.
Anthony is one of the Markforged technical experts out here in Australia. I got a couple of questions that I've got here that I want to throw at the group, and if some of them might be right for you to chime in on, Anthony.
Sure.
Got a few that are kind of material specific, right? So I guess there's a lot of interest in that aspect of it. In particular, I guess the Ultem. And so the first question was, what temp can Ultem 9085 handle?
So the heat deflection temperature is 175 degrees Celsius. So it's much higher than Onyx. Pretty standard, pretty simple answer for that one.
Okay, that's nice and easy. Bash that one out of the park. Let's see if we can test you a little bit here, hey? Okay, here's another one. Can Ultem and Onyx be printed in the same part? So obviously two different materials. One's a chopped carbon fiber, one's the Ultem material. Obviously maybe a more experienced Markforged user there, interested in whether or not there's a multi-material option.
So the short answer is no, but the longer answer is we always start with the application. So when you're considering to print a part, you should understand why you want to print that as opposed to other manufacturing methods, and then we start to look at the design and the material. So if you need to be resistant to certain chemicals or have a certain stiffness or hardness, we start from the ground up, and then we can choose the material, the design, all that sort of stuff. So I'd be very interested to know why you would want to do that, and if we can find that out, then we can sort of work towards to the design and choosing those materials.
Thanks. I got another question, and I think I know what the answer is going to be, but and I'm not sure whether you're going to be able to answer it. Are there any new continuous fibers coming?
That's our secret source. So we have ramped up a lot in the last, I guess, year or so, like in terms of the number of employees in Boston on research and development. It is amazing, seeing the growth of Markforged, and a lot of that is, into developing new hardware, software, materials. So, watch the space.
Yeah, is there anything that you can share around other materials that are kind of about to come out, or I know we know the Ultem's coming. Are there any other materials launching other than maybe not fibers?
I can't share too much specifically, but in the very near future, we're looking at the whole process of product development. So at the moment, Onyx is like a really great material for end use parts. It's very strong, all that sort of stuff. But what if you just want to do, you're in the earlier stages of product development and you need something a little bit faster and cheaper? So, you know, I can't share the specifics at the moment, but
Yep.
we are looking at, you know, each customer and their needs and hoping and going to cater for those needs.
Yeah, cool. I mean, and obviously there's, you know, there's more material than just Ultim and Onyx with, you know, with the Markforged product already. You know, you've got the fire retardant material, you've got the ESD, the electrostatic dissipative material for the electronics application. So, you know, please don't just get hung up on, you know, on Onyx and continuous fibers. There's a number of different materials across the Markforged range which have, you know, various applications. So, you know, just keep your eye on that. A couple of other questions, more around, I guess, things like repeatability. So, you know, what's the kind of repeatability like on the FX20?
So I guess the repeatability is sort of similar across our industrial range, and that's something that we focus on. At the moment, the best tool that we have for repeatability is a software called Blacksmith, which is on our industrial printers. So basically what you can do is that you can compare a point cloud that is generated during printing with the original STL, and you'll be able to see a report and a 3D file showing exactly what the deviation is of that. So I guess with Blacksmith, it's an AI software. So the more you print it, the more it learns, and the better repeatability you're going to get. But we're talking within tens of microns here. It depends on part geometry, but it also depends on the tools, the software tools that you're using as well.
Yeah, great. And interestingly, one of the questions was, does Blacksmith work with the FX20? So I think you covered that off during that answer. Yeah. Cool. We know there's a laser scanner in the X7. Is that the same in the FX20?
I believe that's getting sort of more deeper into the product side of things. I believe, you know, my first sort of memory is that it is a slightly different one in the FX20. The FX20, all of the hardware is a step up from the X7. But if you want to, you know, email us, I can double check that and get back to you.
Yeah, sure. Just a couple of other ones here. Is the 800cc Onyx spool compatible with the FX20? Not sure why you'd want to do that, but
no, yeah, yeah, I believe it is. Yeah, but as I said, yeah, I'm not sure why you'd want to do that. You'd end up sort of changing spools all the time.
You'd end up running out of material.
Yeah, exactly. So it doesn't practically sort of make sense.
Yeah, and then are there larger spools of continuous material for the FX20?
Yes, there will be. Yeah, so obviously, you know, we have much larger Onyx spools, and we'll need much larger continuous spools, you know, to support that as well.
Yeah, great. Thanks. And then just one last one around site power requirements for the machine.
So that's something, you know, it's probably best to have a conversation with us. So, you know, obviously we have a range of products, you know, ranging from the Mark II to the Metal X. The FX20 is pretty much plug and play. There are a few things you need to be aware of, but it's best to reach out, you know, to us, and we can chat about that.
Yeah, sure. Sorry, a couple of other ones that are just coming through in the as people are kind of the creative juices are flowing, obviously out there. How does Eiger software guarantee data safety? Is there a non-online version that you can use?
Yeah, so basically, yes. The answer is that we have lots of defense customers. We have huge customers like Toyota who require this sort of thing, and it is possible to have an offline version of Eiger, which is a subscription model. which is not connected to the internet at all. However, the vast majority of our customers use the online version, which is guaranteed by ISO 27001 security certification. So if you can look in, if you look into that, you can have a look at how significant and serious that is. And I guess everything is sort of moving into the cloud at the moment, and there is a little bit of fear. I completely understand that, but there are sort of certifications that exist, to guarantee that data security.
Yeah, and look, I guess kind of went back to something that Richard was kind of saying during his presentation, right? That the whole system is connected and feeding back certain information, and using that to refine a product, pushing over the updates out. It's not dissimilar to, a Tesla kind of business model, right? People are driving cars around that's happening to, and that's considered to be, a competitive advantage for a Tesla over something else. So, I think I think that whole connectivity thing, is helping to build a better product. A couple of other questions coming through here. And I'm not sure what this means, so and maybe you do. Is there any possibility to construct RCC building using 3D printing technology? And I've got to be honest, I don't know what RCC building refers to.
RCC, I am not sure. I'll just see if Google will tell me. No.
Okay. Reinforced concrete.
No, I'm not sure what reinforced concrete. Well, if it is about concrete in the construction industry, we do have a few clients using it for that industry. Typically for one area is, I guess, safety, and little like guards and things for equipment out on site.
Yep.
But I am not sure, what RCC refers to.
Okay.
But,
yeah, no, that's a good. Maybe I'll follow them up directly and find out a little bit more about that. Got just one more here. The Ultem 9085 material described, I'm assuming, is the same as the PEI-based material originally by Stratasys. Will there be any difference between this Ultem and the Stratasys Ultem?
Yeah, so Ultem 9085 is a standard material. It's been around for a long time. We do have our own version of it, which is black in appearance. So I guess the beauty of this material is because it's been around for such a long time, it has a lot of proven applications, and there has been a lot of studies done with it. So in terms of looking at the material itself, there is a lot of predictability there, but the end part isn't going to be the same. Like our technology is different to others, and we take pride in our surface finish and the strength of the end part, especially when you include continuous carbon fiber.
Yeah, I think you touched the key there, right? Is that you guys can inlay a continuous fiber within that part, whereas my understanding is you wouldn't be able to do that on a Stratasys device. So, you maybe you're adding fiberglass in there, or you're adding carbon fiber in there, or something else that's going to increase the strength properties of that part.
Yeah, exactly.
I got one other. Does Markforged have a device to test the strength of end-use parts, e.g., for a mix of onyx and composite materials with a continuous fiber reinforcement? I think that would be a no, right? Typically, you can get specs on how those materials perform, but ultimately, that would be based on your part geometry and what it is you're actually trying to physically make using the onyx and carbon fiber, for instance. So, you might need to go to an external company to load test or do something like that to actually understand the integrity of the part, right?
Yeah, there is some FEA available with MSC software, but
Yep.
if we look at the practicality of things, then when you consider design for additive manufacturing, you can do destructive testing very, very easily with 3D printing. It doesn't take much time to create a sample and destructively test that. And typically, a physical test is still more accurate, than FEA. So we still encourage destructive testing.
Just one last one. They're still kind of coming through. How do you know how much carbon to add?
So I guess that's where Markforged University comes in. Markforged is very much, it sort of uses some basic engineering principles. I actually studied civil engineering as my first degree, and I use the reinforcement with concrete education that I had a lot. So Markforged University helps, and a little bit of experience helps as well.
Yeah, cool. Thanks, Richard. One more. Every time I say one last question, another question comes in. So I got another question for you. This is a good one, actually. Got a couple of good ones from Oscar. He's just said thanks for answering the question around the Ultem material. Ultem being considered space grade, is it known if reinforcement materials could compromise this, particularly in relation to outgassing and HDT?
It won't affect the HDT. Outgassing is a interesting one. So when it comes to space, we have lots of applications in space, especially in the tooling. However, we haven't focused on, like, for example, the interior of a space station and the certification required around outgassing. So that's something that we can work with you if you want to do testing yourself. But we certainly have a lot of proven applications for space, before you sort of reach that particular application.
I think, Oscar, it'd be interesting to talk to you offline about any particular application you have around that, and to see whether or not there's more information we can provide around outgassing, and maybe plug into some technical experts in Boston, right? That's all the questions, so I'll close off. Firstly, I say thank you very much, Richard. It's been a pleasure having you on, and always very much appreciated. Anthony, yourself also, thank you very much for joining. And also to all of you out there who have joined the webinar, thanks for your time. Looking forward to talking to you all in the near future. Have a great afternoon.
Giving shape to ideas. Konica Minolta.